Hello world, and welcome to another video. This time I've got a very nice MSI Cyborg 15 a13v. This is one which has been said has no power. Turn it on and nothing. No signs of life or anything. Not sure if it takes anything with the charger. We'll plug it in and see. Oh, that's good. 0.2. Sitting at 0.2. Still sitting at 0.2. Constant current. Yeah, constant current at 0.2 is never a good sign. So let's have a look and see if we can figure something out with this. Pop the screws out and see where we go. Another cracking day in Blighty today. Sun is shining. Birds are singing. Great to be alive. Not as many screws in this one as we did in on the other day. I think I counted 61 screws in one the other day. So it looks to be all out. Let's see if we can just assist it coming apart. A little bit of gentle persuasion, and as if by magic, we have a very nice laptop. Okay, it was reported that it's had the RAM changed and not worked since the RAM change. So this plate goes over the RAM as a shield. So I'm just wondering whether when the RAM's been changed, whether anything's been knocked off or damaged. So I'll have a look under the scope in a few seconds. Just now we've disconnected the battery. I'm just going to see if that current draw has changed. We were getting 0.2 before. So we're just going to check the current draw now to see what we are at without battery. I suspect it's probably similar because it wasn't charging voltage. So straight up to 2, just sitting at 2. I don't think it's going to alter from that. So there's something drawing 0.2 of an amp on the board. So I'm just going to disconnect a few other bits and bobs on the board just to make sure it's nothing that is shorting out on any of the components. Just change the screwdriver bit. I'm aware that you can't see this too well. I do intend on getting a bit better system and getting it rigged up to the power supply, which sits at the bottom here, so it can be seen easier and better. But that's a job for another day. Love to see big thick pads on there. So I'm going to reset the BIOS as well just by popping the battery out. We'll just take the RAM out, which is what has been reported as being swapped, and I'm just going to try the current again with the charger. Yeah, straight up to 0.2. So it's none of those we've taken out, so we've eliminated these things as being an issue. So we'll just put those to one side. So what we'll do, we'll just bring the scope in, and I'll swap over to the microscope screen so we can have a look together. Zoom out a bit so we've got a bit of a clearer shot and a bit of a wider angle. And we'll just have a quick look around the board, around where the RAM is, which sits here, just to make sure we can't see anything which is any small components which may have just been. Turn the lights down a little, just put that one on, just try and balance it out. I'm looking at a polarizing ring. If anybody's got a solution or any advice on an affordable one, there is one which I've seen one of other streamers use. I did price that one up, it was about £140, which was more than what I paid for the microscope, so I don't really want to be spending all that at the moment. Maybe in the future, but as it is at the moment, don't really want to be doing that. So, not seeing anything currently, just looking around where these are going, where obviously the line of the frame of the shield would normally sit into these, and it would grip it. So just want to make sure if it's just been taken off. Slightly unsquare, you can see that's these haven't been put on brilliantly, because that one's been bent inwards that way and this one's been bent outwards. So so that could have caused something. And also, if they've not had the battery disconnected when they've done this, they could have put this across and maybe shorted several things together. You just never know. And there's certainly a lot of the power stages down here, with the Q, which is on the power line, I believe, to that. Okay, so I can't see anything which is jumping out at me which is been knocked off or ripped off. So what we'll do, we'll get the machine that goes beep, and we will put a little bit of continuity into the system. So I think that's already on beep mode, continuity mode. No matter how I keep these wires, they always seem to tangle up. The tangle fairy's been round. So we'll just find an earth. I'm just connecting it up to the USB socket on just there, just to find a decent earth. And we'll just test. Flick these back to the other cam so we can just see it a little easier. So I've got an earth on here, and we're going to just see if we've got any shorts on the board anywhere around here. So we'll test the coils. So that coil's good. This coil's good. Cracking, that's reading good. This one up here, 31 ohms. That'll be feeding the GPU and CPU. Same as these. No short on those. Or no continuity. Got one down here, and we've got those on there. So there's no short on any of the coils. So we'll just test the MOSFETs. So that one seems fine. No shorts on those MOSFETs. Current sense resistor, no short. There shouldn't be any shorts on any of those either, because those there are, sorry, you can't see because of the scope. These here are for the Ignore the machine that goes beep. Just moving the scope up. And we might, if we can get this out, might be able to just get a little bit more of the board in on the scope. Okay. So just going to have a look at where the power comes in, which is obviously up here. So the power comes in here. That's the beep for the chassis. We've got the power coming in here, power 1. So that'll be earth, ground, sorry, on those. And then it looks like it goes through these. There's no short there, which is good. There's no short on that MOSFET coming out. And there's no short coming on there. And that's the current sensor resistor. So no short there, which is also good. So it was still showing the current draw with or without battery in. So the battery charging one is down here. Nothing on there. No shorts there. So this says to me that if we get the thermal camera out, we may just be able to see something getting a little bit toasty and a little bit warm with the thermal camera. So let's get it rigged up and let's see what's what, and just see if we can see what is getting a little bit warm, a little bit toasty on the camera. So just give me 2 ticks to get this plugged in and on. It's the Unity 260B camera, and I hope that's not deafened anybody by coming on. I just want to see if we've got there we go. So we should have the thermal camera up here, and if we look here, we've got a thermal camera. So all I'm going to do is plug the charger back in and just see if there's anything under the camera that's getting a little bit toasty, a little bit warm, or anything else as such. Just get the macro lens just in case we need it. So I will put the supply back in. We are pulling 200 again. Oh, what's that? Straight away something getting hot up here. Okay. Yeah, 74 degrees. We've got something under there getting a bit warm. So let's just flick that back onto the scope. The area it was getting warm is this thing here. Okay. Which is, not sure what that is. So let's see if we can just come down a little because I moved the camera right up. Just talk amongst yourselves while we do this. There we go. So what is that? Whatever it is looks to be, I mean, that's getting to 70 degrees. Should it be square on there? That looks to be just a pad. There's nothing wrote on there at all. So should we just get the macro lens on and just have a look between us? Get that back down there. Put this back onto the thermal. And let's just plug this back in and just to see where it is coming up. 200. No, it's that little power regulator chip just there. Yeah, we'll unplug that. So it was very close to where we were looking, but with the macro lens we can see a little bit easier. and it is that one just there. So I'm really not sure what that is until I get the scope so I can read what it says. Fortunately, my eyes aren't that good. There we go. It's a 1225C, and that is getting up to 93 degrees. Let me just double check that it is that and nothing else around it. Then we can just double check it. Yeah, 93. That's just not very well, that. So we've got a short somewhere around there, or actually on the chip itself. So let's just have a look around there just to see if we've got any other shorts to ground. So we've got the machine that goes beep. I'll just find a nice earth again. Oh, sorry, nice 0 ground, which will stick on there. And we will get that back onto scope so we can all see what I'm doing. So this is the chip that's getting up to, well, I'm sure if I left it plugged in, probably around 100. So just make sure we have got, yeah, we've got it ground. Ground at that side, 0.2. 0.2 at that side. So that is more or less coming all the way through. 0.2, 2.9. Right, so this chip here is getting incredibly warm. Yeah, so that's actually ground anyway, because this is current sense resistor. That's obviously the positive side of it. This is negative. That's negative, 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 and obviously this is negative as well. And then this will be positive. So we've got no short on the capacitor, on the MOSFET there. So we are going to be looking at why that little beauty has gone pop. And then just get it back into focus so we can. There we go. Just turn the brightness down a little. So let's have a look what that chip is. So we visit our magic friend on the internet. 1225C datasheet. It's a dual synchronous step-down controller with 5 volt and 3.3 LDO. It's got an input voltage range of 5.5 to 24 volts, and it's got an adjustable, so it basically steps it down and regulates the voltage. So according to the pins, we have 1, 2, 3, 4, 5. So there's 20 pins on there. Let's have a look at the pin layout. Just skipping through the data sheet just to try and find the pin layout. Here we go. So according to this pin, let's get rid of the garbage around it. Find it on the board. Some gunk on there. what that is. So let's see if we can brush it off. A little bit of Monica by my side. I mean IPA. There we go. Is that just screen print? Is that what it is? Zoom down. Try and keep it in focus. I'm not that keen on this microphone stand, I will stress that. Got a lot of shaky cam. There we go. Yeah, it's just ink, is that one. So pin 1 looks to be up here, denoted by the dot. So I'll just get my drawing back up and we will see what's what. Pin 1. And the pin. Right, so we've got voltage in, which is pin 12. So we've got 5, 10, presume that's 10, 11, and then 12, which goes to there. So that's good, there's no short on there. Pin 13 is a voltage pin also. No, nothing on there. And then we've got pin 17. So 16 and 17 goes to there. So no shorts there. Pin 20 should be an enable pin and there's nothing on there. So just looking at that, is that getting hot because it should get hot? Or is that getting hot because there is a short on it? Because according to that, pin 1 is not. Okay, there's nothing there that I can see which has got a short on it, and your thermal pad which sits underneath the chip is obviously ground. So there's nothing there I can see with a short on it. So pin 10 is the high side driver output. So we've got 5, 10, so that's the pin 10. So that's definitely not shorted. You've got pin 15, which is the low side, so 10, 15, so that would be pin 15. Channel 1 enable, channel 2 enable, which is pin 6 and pin 20. Well, we've tested pin 20 already, which is there, and pin 6 would be that blob of solder just there. Right, so pin 17 and pin 9 is supply input for high side MOSFET. So pin 17 and pin 9. So again, 5, 9 would be 9. Definitely nothing there. And pin 17, so 15, 17 would be that big boy there. And again, there's, sorry, 16, 17 is that capacitor just there. Did I touch that before for something? Maybe I did. Can't remember. Should have been that pad before. So you've got pin 14, which is output voltage for 5 volts. So pin 14, 5, 10, 14 will be one before that, which is that one there. And again, there's no ground, and the ground is the thing. So pin 3 should be 3.3, pin 13, so pin 3, which is that one there, we've got a 4 ohm short, don't know if, or 3 ohm short. So does that mean the 3.3 rail has been shorted? Pin 13, so 5, 10, 13, 13 would be that one there, that big boy there. So the only one I've possibly got a short on is that one there. Yeah, so should we just measure the resistance? Just flick that over to resistance. Sorry, it doesn't show on your screen as resistance, but that is now in a resistance mode. I just want to see if I've got a short through this cap. One side on there, one side on there. 2.8 ohms. Is that normal for a cap, or would we say that's a little bit low? And the other caps around there, that's mega ohms. Mega ohms. Nothing. I mean, some of these will be doing it in circuit. Mega ohms. So that one there is 2 ohms. Well, it is about 2 ohms because that's my leads now which are reading that. So do we just pop that off and see what's what? Do we see if that gets rid of the heating up temperature? Well, that's the only thing I can see on there which might be of concern. So if we whip that off, and I can always pop it back on if needed. So we'll just pop the a13vf air station on. I'm just thinking with this, I'll set it to, I want airspeed right down because I don't want to be blowing stuff all over the board. So I might start at 25% air. And start at 20%. Don't really want to do any damage to anything, so I'm going to keep it nice and gentle on here. And we will see. Just give that a grab. We'll get a bit of warmth on there. Bit of sunshine. (25 or 20% air, 400 degrees C). It is a thick board here. A gentle wiggle. Don't think that is on a ground pad because obviously ground's underneath, and it's going to knock the airspeed up in a little bit more heat. So that's 420 at 25%, and it's the a13vf ST862D air station that I've got. So we'll just grab that. Wow, this board is a thick board. It is a gaming machine, and it is a nice quality machine. Doesn't seem to be want to budge that, so let's take that up to 450. I've managed to melt the little plastic pad near it, so it's obviously getting some heat transfer. I don't think I need any more airflow. There we go. Little beauties off. I'm going to keep that to one side. Just put my air thing back. So we will take that out, which we've done there. And I'm going to keep that to one side, near the screws. And we're going to just give this a gentle cool down. There we go. These little air blowers nowadays use different lowest setting just to cool the board down without giving it any thermal shocking. They do work very, very well, and they're not overly noisy. Okay, so that's it off, and that's it cooled down. Just gonna flick the thermal. Sorry, I'm just gonna plug the back onto all, and we're just gonna move that to one side, just so we can see this, just to see if it's still pulling the 200 when I plug it in. It is still pulling the 200. So, is it still that getting hot? Just look at the thermal camera, which is up here. Yeah, it's one of them over there. So this is the thermal camera. Just gonna stick that in there, and we'll just see. Yeah, it's still that same thing. Getting a little bit too toasty. 100 degrees. Let's get it out. We don't want to be doing it any harm, do we? So it does look like it is still that. So I'm just wondering whether it is that chip which has gone, or is it something supplying that chip which has gone. So let's just put that little capacitor back so we don't lose it, because we don't want to be removing things which doesn't need to be removed. So I'm just going to put the scope back in place, and then I'll flip you back onto the scope, and we will make an attempt at getting this back in place. So let's get I will just measure this capacitor before we go any further, but I've got a funny feeling that the capacitor should be fine. Put that there. Still got the meter in resistance mode. Very, very small, this. Yeah, so it's the circuit. So we'll just put this onto ground. So that is a resistance of 0.16. So bearing in mind I'm just going to move this up just to see if we've got a bit better viewpoint, a bit wider option for us, so we can all see what process I'm thinking. So just before we put that back, if we just put this on something metal, something ground, and we look at my probes are reading as 0.14. So let's just zero them out. We've got a zero function on the meter. And I'm just going to change the speed down to medium speed. There you go, medium speed, and just zero the things out. So if we now look on here, we've got that pad there, which is reading, that's a direct short, that. And we've got that pad there, which goes directly to the chip, reading at 2 ohms. So that just could be right. But this one, which is a resistor, which is reading at 4K, but this side of the resistor, it's just whether that should be ground. So let me just have a look again at what that pin is, So if that is a capacitor, it could well just be a filtering capacitor down to ground, do we think? So that's probably right. So that would be pin 1, 2, 3. Pin 3. And let's just see what pin 3 was again. So pin 3 was the 3.3 LDO output. I don't really want to plug it in and check that. I think this is generating the 3.3 and it's getting rather warm for that. So let's put that little capacitor back before we lose it. Because we don't like misplacing things. Not something so tiny, because we'll never find it. Should be close enough. Turn the magic dial to bring everything back into semi-focus. Get the hot air station again. Just flick it on. Just going to turn the air down a little because I don't want to blow this away. And I think 25 was a little bit high. So we're going to try it. There you go. Nice round number of 18. I'm just going to grab this best I possibly can with my shaky hand. No coffee today for me. Put some heat into the board first because I think I'm better off just putting a bit of low melt on. Not low melt, but a little bit of leaded solder. That might make it a lot easier. So that's what I've seen people doing, and I'm forgetting the process. So we'll just stick that back in there. We'll get the old or the new soldering iron plugged in. And swap my tip out for my small conical tip. Turn her on and get the solder out. I'm using this mechanic solder, which is SX862. Excuse the noise from the hot air station if you can hear that. It's just having a moment. There we go. So we'll just put a bit of flux. This is the, you won't be able to see this, Amio flux. I've been trying this. It's the M53 clear flux. It's okay. Can't say it's really floating me about too much. Flux is a bit of a strange one. So we'll just get a little bit of leaded solder down here and we'll see how we go. A bit on there. Using the smallest tip that I've got this. Just going to wipe that off a bit because I know what will happen. I'll end up putting all that down there. Just do we spinning the board actually because it's the wrong orientation for me soldering with my arm. So I'm just going to move the scope across and we'll see if we can find the right orientation. There we go. Back to where we were. I wonder if that's a ground pad because that's taking some. That's actually sticking the iron. No, it's not ground actually. Sometimes I just need to stop talking, don't I? But I think that's thoroughly mixed now. So we've got plenty of leaded, sorry, solder on there. So we're going to get the offending capacitor back on the board. We get the a13vf ST862 hot air station. Just knock the airspeed up a little. We're going to get the capacitor gripped and we're just going to warm that up. Wow, that's hot, burning my fingers. Anybody would think it's hot air. I'm going to nudge that with my iron. A little. Tell you what we do need. We need some of that magic liquid, don't we, called flux. There we go. We'll give it a bath. Give it a bit of lube. One side on. There we go. I'm sure everybody in the wide world will be going, hey, do you know what, that's not how you solder. But hey, I'm still learning. Imagine what it was like when you were learning. Did you just wake up one day and go, I can solder? Probably not. Okay, so we've got that soldered back on. Give that a bit of a clean with the IPA. It's always nice to just make sure things are cleaned up. More IPA. Faster than lightning, that. So we now have that chip which is still getting hot. So let's just go back to resistance mode. Just going to find a screw hole again. See if we can find a screw hole. And it was that one there, 4.25k. That's 0.6. So I've got to presume that that is ground, because that'll be, that's the, that one's the 3.3 LDO line. So I don't really want to plug it in and start testing voltages if that's the case, but we've got 3 ohms on that. Which is more or less shorted through if you look, but it's not because I've tested the cap. So does that mean we've got a short somewhere else then? I think it probably does. So let's just get this wound back up and have a look. So should we see if there's anything else getting a little bit, let's just spin this round. Anything else getting a little bit warm under the scope when I plug the power supply back in. So see if there's anything else getting a little bit warm under the scope, under the camera. So I'm just going to plug this in. We're back to pulling 0.2. We know that that's getting warm, but is there anything else? No, it is just that. And let's just double check, just for sanity's sake, that it is just the chip. Let's just get the chip in focus. Yeah, it's dead centre of the chip. I'm thinking it's that chip which has gone. So I'm thinking it's that chip which has blown. They have changed the RAM. There are obviously other bits and bobs around the area, because this is where the RAM is, and this is where this chip is here. It's a 20 pin chip. So I'm thinking when they've changed the RAM, they've done something which has blown that chip. I'm going to look at ordering one of those chips and see what they are, see how much they are, and availability. And we just might need to revisit this on a later visit, just to see what's what, and hopefully then be able to sort it and see if we can get a conclusion on it. But if anybody else has anything in the comments, please do let me know, because like I say, this is the start of the experience, the journey. Yeah, I've got over 1k there, but there's nothing replicating the 2 ohm short on any of the coils. I mean, there's less than 1k there, which is the GPU on that one. But I think I've tested these already. Because it's not actually cutting the supply out, so it's obviously not on the power side, because the meter's not tripping. It's just doing a constant current draw. And with this little IC sitting here, this chip is a dual synchronous, just rolls off the tongue, dual synchronous step down controller with 5 volt and 3.3 volt LDO. It's the TPS 51225, and it comes in a few flavours, B and C, as well as the standard one. So I'm just going to put this on voltage DC, leave it on 5 volts, and just see if we have got a 3.3 on any of the coils, because I think let's just put this on here, because we know where the 3.3 should be coming to on here, which is there, that pin, that amazing solder on that capacitor should be 3.3 on there. It's pin 3. So if we flick the power on, we've got the current draw and we've got half a volt, and that should be 3.3. Pin 4. Again, just let me get down to the correct page. 32 pages long, this data sheet. So finding the right. So pin 3 is... So pin 13 should be the 5 volt for the LDO. So pin 13 is the middle one at that side. So more or less opposite where that capacitor is. So this should be the 5 volt. I've only got half a volt on there anyway, and there's nothing on there. So 17 and 9 is the input. So should we just measure 17? 17 is that one there. So nothing on 17, and 9, which will be that one there. Nothing on there, and the chip is getting hot, hot, hot. So pin 14 is a voltage switch. So pin 14 would be that little blob just there. Just zoom down on here so I can see it a bit better. Sounds like me on a morning, this. So 5, 10, 14 would be that pin just there. Yeah, so there's nothing on there. Which one's the enable? Enable's pin 20 and pin 6. So pin 20 is an enable, and pin 6, which looks like it goes to that blob just there. Half a volt on pin 6. And pin 20 doesn't look like it's populated on anything. Half a volt on there. Yeah, if anybody can shed any light on this, it would be much appreciated. It's certainly a one for me to learn with and see what's what and everything else. that's just a bit dirty with flux and whatnot. We'll give it a good clean, as and when we figure out what else we're doing with it all. Because I think I'm going to have to probably order that little chip there. And is it that this chip has gone because the RAM has been changed and they've shorted something out? I don't know. Don't know. So we're going to leave it there for that. And please let me know in the comments or what you think it might be, or any other possibilities on that, and then we'll see where it goes from there. But that chip getting up to 100 degrees C, and we've got a constant current on the power of 0.2 amp, and we have got a short on there of 2 ohms, 2.6 ohms I think it was, something like that, and that's on the 3.3 LDO channel, and there's no other voltages off that. So is it that? Is that just trying to work a little bit harder? Or is it trying to do something it shouldn't be doing? Is it shorted out? Is it a direct relation to where they've changed the RAM? None of the coils have got shorts on, and the meter isn't actually, the power meter, the power supply isn't tripping out. So it is sitting static at that, and that is getting toasted. So yeah, please let me know in the comments, and we'll see if we can revisit this shortly over the next couple of days if we get some suggestions. If not, I might just end up ordering one of those chips. The one, just get that back in. Just turn the brightness down a little bit, and then it enables me to read it. 1225C IC chip, which is the dual synchronous LDO and 3.35 volt step down. So yeah, I might end up ordering one of those and give me that a shot, and then it can be a bit of a learning exercise as well. But please let me know, like and subscribe, and it's much appreciated if you can just hit the subscribe button or even the like button, and then we can see what's what and where we're going with it. So have a super day, guys and gals, and we'll speak soon.